Good morning, everyone. Welcome to this webinar covering Dell wireless networking. My name is Chris Chandler, and I'm one of the IT consultants here at Nexus Open Systems, who works with Dell, with our clients to provide solutions based around the Dell networking portfolio. This morning we have Barry from Dell, who will be presenting the content to you. Just to ensure that you can hear me, if somebody could just make a note in the chat to say that you can indeed, that would be very much appreciated. At this point, though, I would like to hand over to Barry to crack on with his content, and thank you again for joining. I'll jump in at the end.
I think I was on mute there, actually talking to myself, so I'll say that again. So thank you very much, Chris. Morning, everybody. Hopefully you can hear me now. My name is Barry Griffin from Dell. So if somebody could please just type in the box and let me know whether you can hear me or not, that would be much appreciated. Perfect. I've got a good loud and clear. So I'm just going to take over as the presenter now and launch into my presentation, which is all about the Dell wireless solution. Okay. So, just messing with the technology here. I hope that's in my presentation. Can you see my presentation on the screen? You should have a PowerPoint entitled Dell Wireless Solutions for Next Generation Enterprise. I'm hoping that you can see that. Okay, that's still loading. Do my best. Right, can you see my presentation now? So we should have a title screen on there, which is Dell Wireless Solutions for the Next Generation Enterprise. Thank you, that's good. Right, okay. So what I'm going to talk to you about this morning, so probably over the next 45 minutes, is the Dell W series. And I've entitled this slide actually the Next Generation Enterprise. Probably more valid for the enterprise of today rather than next generation. So what we're seeing of a typical enterprise customer at the moment, and these are the main drivers for what we have in our portfolio, is a big take-up on devices. So if you are sitting in an office right now, you can probably look around you, look on your colleague's desk, you'll probably see a laptop which is wirelessly connected, maybe a tablet, a couple of mobile phones, and there's a big uptake on apps. So iPads, Windows tablets with their app centers. Users are downloading more and more applications. A typical user would probably have somewhere in the region of 30 to 40 apps loaded at any particular time. And year on year, those applications are actually testing out networks in terms of bandwidth consumption. What I'm going to talk to you today is, what those challenges actually mean, when implementing a wireless solution. With the number of devices, it's those devices and the applications that they're supporting are actually testing out the network. So more devices than the network can actually cope with in terms of capacity. Another issue that we're seeing is the devices themselves are actually taking the decision as to how they attach to the wireless network. So not necessarily making the best decision. Okay. So what I mean by that is probably, connecting to an AP which is perhaps suffering from congestion or even some degradation of signal, or probably not connecting to the best available channel. Another issue with some of the older wireless networks is around QoS. Okay, so perhaps able to provide some quality of service, perhaps at an IP level, or perhaps at an individual device level. But with the uptake of tablets and iPads, where it's actually a converged device connected onto the network with multiple applications, what you really need to be doing is be able to apply QoS to the specific applications rather than device. So having visibility into the application. And the same thing applies to VLANs as well. So some of the older wireless LAN products, security would be applied on a VLAN basis. Again, this is no longer adequate when you have multiple applications which could belong to different VLANs, or when we're looking at mobility. So that model no longer works. And lastly, not all enterprises are equal. And what we mean by that is that, what is the definition of an enterprise customer? Okay, so this could be, a single office. It could be, a very large spread campus environment. It could be an office environment where there's requirement to bring on some remote users. Okay. So the Dell solution, we believe, addresses all those. So it's the Dell W series, which is our wireless offering. Okay. And some of the key features that we have that really address some of those challenges that we've just looked at around implementing wireless LAN network in this next generation enterprise, or more valid, the enterprise that we're seeing today, is firstly around the adoption of 802.11ac. Okay. So all of our products in the portfolio right now are supporting the 802.11ac technology. So the family of access points that we have, the 200 series, will all support 11.ac, and also the controllers as well, if we're looking at the controller-based solution. We have some clever technology within our controller, so whether that's a virtual controller solution or appliance, okay, which means that we always optimize the airspace. One of those features is a feature that we call client match. Okay, so this gets around the issue of the devices themselves making decisions about what access points they connect to. Okay, so what we call sticky clients, so where a client might attach to an access point, associate with an access point, which isn't necessarily the best access point to connect to. Okay. And we'll have a look at that in a little bit more detail in a second. We also have a technology, an embedded technology called AppRF, which means that we can inspect the applications themselves. Okay, so we have a policy enforcement firewall, which is essentially an application layer firewall. Okay, and what that allows us to do, it allows us to make decisions, so take a policy action on those particular applications coming from a specific device. So, we've got some examples there about applying QoS for multimedia. So Link in particular, is a good example of that. So Link, in itself is a multitude of applications. Okay, and we can drill down into the specific applications within Link and apply QoS rules as appropriate. We support AirGroup. So AirGroup is a group of applications supported by Apple. We support the Bonjour service, or supported by the Bonjour service. And again, we'll have a look at that in a second in terms of what that means. But it's about optimizing the infrastructure for supporting things like AirPlay, AirPrint, within an enterprise. Okay. AirGroup is really designed for home user network. So yeah, we have the embedded security with the policy enforcement firewall, but we also have wireless intrusion protection as well, okay, which is detecting potential threats on the network and mitigating against them. So it's what we call protect the air. Move on and have a look at some of these features in a little bit more details, and also have a look at the product sets themselves. So does your organisation fit the solutions? And for some vendors, this is probably applicable because, whether they're selling a cloud-based solution or a controller-based solution, what they'll always try to do is they'll try to adapt, the one architecture that they have within the portfolio to fit your environment, okay, which isn't always the best way of addressing that. Okay. So the Dell networking architecture really allows quite a lot of flexibility in terms of how that architecture is deployed. Okay, so it's not a single architecture that we have. So it's a single set of products, of technologies that all come under the umbrella of Dell W series. But we can address, any kind of environment that a customer might need. Okay, so whether that's a large spread campus with hundreds of APs that all need to come back to a physical controller or a cluster of controllers, okay? Or whether you have a head office and branch environment, okay? So you might need some core appliances at the core, and maybe a distributed environment of branch controllers, or whether the environment just doesn't need or warrant physical controllers. We can build a network of virtual controllers using our instant AP solution. Okay, and we also have a remote access solution as well. So whether that's home office workers, whether that's mobile workers, okay, we can provide a solution where we have a remote access point which will connect back into a controller using a secure tunnel, okay, across an unsecure network, i.e. the internet, from a home office or Starbucks. Or we have a client that actually sits on a PC, which effectively does the same thing. And for both of those, we can push the same firewall policies out as if those users were actually sitting in the enterprise network. Okay. So the two main architectures that we have are controller and controllerless. Okay, and looking at the components of those, very, very similar. Okay, in terms of functionality, the differences are in terms of the actual physical equipment that's needed. Okay, so in a controller-based architecture, we have access points which provide connectivity for the end users. Okay, and they will be either logically or physically connected back to an appliance, and it's that appliance that has full visibility of that wireless infrastructure, has full visibility of what each and every access point is doing. It's a single point of configuration and management. It has full visibility of what each and every AP is doing in terms of power settings, RF settings, etc. Okay? And it's the controller that has the embedded firewall and has the embedded wireless intrusion protection system built in. Okay? And that provides access back onto the wired infrastructure, which is ultimately where you need to connect to, where your servers and your applications probably sit in a server room or a data center somewhere. And we can add streamlined BYOD and guest services to that. So streamlined in terms of how we bring those devices onto the network using ClearPass, which is our access management solution. We'll have a look at this in more detail. Okay. And the whole solution can be managed using Airwave. Okay, so Airwave is a wireless specific management application, not only looking at the controllers and the access points, but also giving you visibility into what the devices are doing, where those devices are connected. So those are the components of the controller-based architecture, but we also have a controllerless architecture as well. Okay, it looks very, very similar. Okay, the only difference is, rather than having a physical controller or a cluster of controllers for resilience, we have a virtual controller. So what that means is all that functionality that would sit or reside in a physical appliance will now sit in one of the access points. So this is what we call the instant access point solution. Okay, so we build a network purely of access points. Okay, they all communicate with each other. Over GRE tunnels, over the wired infrastructure, or over the wireless infrastructure if you want, so we can create a wireless mesh. Okay, one of those APs will be the designated controller, and within that cluster we will have backups as well. So we have inherent resilience built into that architecture. Exactly the same functionality in terms of policy enforcement, firewall, and wireless intrusion protection. Okay, and as before, managed by Airwave. Now we can add that streamlined BYOD, so bringing employee-owned devices onto the network securely, minimizing the overhead on IT, or providing self-provisioning guest services. And one point to note is that you can buy an instant access point solution today, which essentially you just go out and you buy the instant APs, and an instant AP will include the policy enforcement firewall, it includes the wireless intrusion protection, okay? And you can deploy that on your network, and that's great. And if you come to a point in the evolution of your business in which you need to change that to a controller-based model, then you're not painting yourself into a corner with this solution, because you can convert an instant access point into a campus access point. So what that means is you can add a controller at a later date if you need to move to that model. Okay, so my question quite often asked is why would you need a controller-based solution? Why would you go for a solution that has physical controllers when you could simply just go out and buy the instant access points and create a lovely wireless network with all the functionality that you need built into it? Okay, so there are some subtle differences. Okay, and I've just listed them on this slide. First one is around data encryption. Okay, so with our controller-based solution, encryption keys are kept on the controller. So from the access point to the controller, all that data is encrypted. Okay, so from the client to the AP, it's in clear text, encrypted at the access point, okay, and then across the wide infrastructure back to the controller, that would all be encrypted. Okay, so if encryption is an issue to you, you need to have that encryption across your wired network between an AP and the controller. That may be a good reason for going for the controller-based solution. Okay, with the virtual controller, there is no encryption because all that data is actually broken out at the access point. Okay, so encrypted between client and AP, but then it's broken out into clear text on the wire. Okay. Second point is around remote access. So, so on the first slide, when I was talking about the flexible options, I mentioned that we support remote users either with a remote access point solution or a client that sits on the PC, which is what we call our virtual intranet access technology. Okay, both of those need to terminate on a controller. Okay, it's not strictly true that an IAP solution precludes you from doing that, because you could add in a controller just for remote access. So it may well be that you like the instant access point solution. That fits nicely in your environment. However, you do want to add some remote access into that. You could actually add in a small controller for remote access. The third point here is around VLAN pooling. Okay, so what we do with the mobility controller-based solution, so the physical controller, is we dynamically allocate VLANs upon authentication. So based on whatever the authentication policy is, VLANs will be allocated dynamically by the controller. Okay. With the instant access point solution, we can't do that. So what we have to do is we have to so the VLANs are dynamically allocated, but they're dynamically allocated at the access point layer. So what that means is there's a certain amount of network configuration that needs to take place. So for every access point where you want to see those VLANs present, then they would need to be configured on the wired network. Okay, so that might be another reason why you may want to look at a mobility controller based solution as opposed to the IAP solution. The last point on here is around scalability. Okay, and although there are no hard or fast limits on or rules on how big you can scale an instant access point solution, it has only been tested to 128 APs. You could probably go beyond that, because it all depends on volumes of traffic and numbers of users and so on and so forth. Okay, but please bear in mind that the CPU and memory that you have in a controller is going to be a lot beefier than what you get in an AP. So there will be a limit at some point in terms of processing and memory ability on that IAP. As a general rule of thumb, we say maybe 100 access points. You could comfortably deploy an instant access point solution. Okay. You can actually create multiple clusters of IAP. So if you wanted to go beyond that, then you could start to break the network down into clusters of say 100 APs and bring those back into the controller. Okay. So really, what I'm saying here is that we have a number of deployment options for you, and it all depends on your particular environment, but it's all addressable on the Dell W series portfolio. Okay. So usually what we'd do is either sales or Nexus would sit down with you and really work out what the best solution is for you. Okay, so just looking at some of the key differentiators of our solution. Okay, and these are key differentiators that we see compared against competitors. Okay, and I'll cover these off, one at a time in terms of what they actually mean. So the first one, own the air. We have a technology called adaptive radio management, okay, which means that we're always optimizing the wireless environment, okay. So we're always providing the best, RF environment, optimizing the availability of that wireless infrastructure for the users. Okay, we'll have a look at that in a little bit more detail in a second. Protect the air. That's exactly what our RF Protect license does, which includes wireless intrusion protection and also a spectrum analyzer. Okay, so it's about detecting malicious threats on the network, rogue access points, but also annoying interference from neighbouring APs. Okay, so that could be the fact that you've got a Starbucks or a McDonald's next door, and your users are inadvertently connected to that. Okay, and we can take an action on our solution to prevent that from happening. Context-aware security. So this is what we do with the policy enforcement firewall. Okay, so we can take a policy action based on who the user is, what group that user sits in. So we can reflect the same groups that you might have in your Active Directory infrastructure. Okay. We can look at device, we can look at the applications themselves, or even where that user is connecting into. Okay, and what we mean by policy action is what resources they have access to. So we can control that to access control lists and VLANs, but also we can apply things like QoS parameters and so on. Okay, so traffic management, in particular, for if we're looking at multiple applications on a single device, perhaps we've got some multimedia on there. And we have comprehensive management and troubleshooting. Okay, so we have a couple of management applications. Okay, we'll have a look at those in more detail. So whether that's just managing the devices themselves at SNMP level, okay, so managing the controllers, providing config and alert management, or managing the whole of the wireless infrastructure in terms of the components, but also the devices attaching to that. So the tablets, the laptops, the mobiles, and to some degree the applications themselves. So just having a look at these areas in a little bit more detail. So adaptive radio management is always optimizing the wireless environment, okay, from a user perspective. Okay, and there's a number of things that we do there. So we're constantly monitoring the RF environment, the power settings. The controller or the virtual controller has full visibility of every AP in terms of how they're performing, what their power settings are, what their RF settings are. We have the spectrum analyzer, which is constantly monitoring all the frequencies within the 802.11 range. Okay, so we have a constantly adapting environment to make sure that we always provide that the best availability that we can. Okay, so airtime fairness and scheduling means that if we do have slow clients attached to an access point, okay, they won't hold up the queue in terms of servicing that access point if you have faster devices behind it. So essentially we time slice, okay, the availability of that access point. Okay, so that's what we call airtime fairness and scheduling. So it's an algorithm that we have on the access points to make sure that all devices get their fair availability. Okay. We do intelligent band steering and client match. So client match, I have a slide on this in a second, is making sure that rather than the clients taking a decision about the access point that they attach to, okay, we can force that client to attach to another access point, okay, if that's going to provide a better experience. Okay. Intelligent band steering, very, very similar in that we can steer a client to an alternative band if there are improvements in that band, i.e. it's less congested. So a client might want to just attach to the 2.4 gigahertz band. Okay, that might not be the best available band to attach to, so we can force that to attach to 5 gigahertz and so on. We can load share across channels, okay, and we can avoid interference of channels by forcing the APs to switch to a cleaner channel or a channel that's not neighbouring, to sources of interference which might have an impact on that channel. We're constantly aware of the 802.11 RF space to make sure that we'll adapt the wireless environment to make sure that there's no impact on our users. Okay, and the last thing that we do, which I haven't covered on here, is in terms of coverage. Okay, so if we do get a failure on an access point for whatever reason, so it might be the hardware's failed, or it might be that there is a source of interference in that particular location. Okay, any neighbouring APs that we have can boost their power to compensate for that hole. Okay, so effectively providing resilience within that wireless architecture. The client match, so already spoken about this. So the way that client match works is that, so in this diagram here, we've got a laptop, an iPad, and a mobile device all connected to the same AP. Because the clients have taken the decision to do that, they see that as the strongest signal, so therefore they will automatically connect to that. We have another AP which is totally unused. So what we do, okay, and we can take this action based on a number of parameters. So whether it is congestion, whether it is interference, whether it's the device type itself. The device may have 2.4 and 5 megahertz channel support. Okay, it's not using the 5 megahertz channel. Okay, so or it could just be simply location. So based on any of those parameters, we can force a client to match to another AP. Okay, if that provides a better experience for the user. Okay, and we can see in this example it will do, because we're reducing congestion on the AP on the left, and the mobile device that we have here, is connecting to an AP which is completely unused. Okay, so that's what we call client match, which is part of the adaptive radio management technology. Okay, so as we said, yeah, it's about optimizing the client experience, so we see that we do get better performance across the whole wireless infrastructure, and it will apply to 11N and 11 AC clients. So wireless intrusion protection, I've already spoken about this. It's all about discovering what's happening in that airspace. Okay, so what we can see, okay, not only what we can see in the air, but also what we can see on the wired side of the network as well. So we can detect access points that are physically connected onto the wired infrastructure that aren't part of our wireless system, for example. Okay, we can look at devices that are trying to connect to legitimate APs on that network. Okay, so we can do a discovery and we can see what's happening. Okay, and then we can classify what we actually want to do. So we can classify what is a rogue AP, for example, what is an interfering or a neighbouring AP. Okay, and out of the box, the system will attempt to do this. This can all be tailored, of course, and then we can take a policy action against that. So those policy actions are all definable within the system as to what action you might want to take. So it could be that you might want to completely blacklist an AP, for example. Okay, or if you do detect unauthorized attempts onto the wireless system, you may want to create a honeypot AP. Okay, so the user, the attacker, thinks they're connecting onto the wireless network, and in actual fact they're connecting to what we call a tar pit or a honeypot AP, which isn't actually connected anywhere. And you can provide alerting and auditing and tracking on this, and we can actually report into the management tool. Okay, so you can actually report into Airwave, and for things like wireless APs, rogue wireless APs connected onto the network, we can take an attempt to even try and map those using the visual RF planning tool. So we can through triangulation on there from neighbouring APs, we can detect where that rogue AP might be sitting within your environment. Okay. So AppRF is the technology that we have that sits within the Pulse enforcement firewall that allows us to look at the applications themselves. Okay. So in the example that we have here, we've got a number of applications. These are, could all be applications that are sitting on the same device. So most of those I've got on my Venue 8 Pro tablet. And for each of those applications, we can apply different policy settings. Okay, so in the example here, we've got a link application where we're increasing the QoS priority. Okay, if we move over to the right on this, we've got AirPlay. Okay, and what we're doing with that is we're supporting the Bonjour service. Okay, by converting that into multicast rather than using the default Bonjour. Sorry, we're converting that into a unicast rather than using the default multicast that Bonjour would use to make more efficient delivery of that service. So some examples again of how that might work. So we've got an iPad here using Link, so we pop that into the high priority real-time queue. We have Box, so we're doing some file sharing, we'll put that into medium priority queue, and then Skype, which is being used for personal use, is dropped into the low priority queue. One of the things that we can do, and we have certification for our technology from Microsoft into this, is support Microsoft Link. So we can support multimedia anyway using the app RF technology. Okay, but with Link in particular, what we do is we interrogate the core control flows using an API. Okay, so we can talk to Microsoft Link server at an API level. Okay, so we have visibility of where those flows are going, what type of flows they are. Okay, so whether it's voice, whether it's video, whether it's chat, etc. Okay, and we can apply call admission control and QoS against that. Okay, so we're the only certified vendor for the wireless offering. Okay, by Microsoft to actually support that. So you can go onto the Microsoft TechNet pages and listed under network devices, certified for Microsoft Link support. You'll see the Dell W series under there. So already spoken about AirGroup, which is a bunch of technologies designed to support the Apple services such as AirPlay and AirPrint, etc. Okay, so these all use the Bonjour service, which was really designed for a home network. Okay, from a wireless perspective, it just looks like broadcast services. Okay, so what we're actually doing with those Bonjour services is really optimizing them. So using multicast or unicast, okay, based on group membership. Okay, So we can do that off the controller by manually configuring where those AirGroup services need to go, okay, and then the multicast will be contained within that. We can also automate that to some degree using ClearPass, which is our access management solution. Okay, so what this allows us to do now is provide a self-service portal for users that need to access, any of those services. Okay, so let's say AirPlay, for example. So a user wants to join that group. Okay, they need to use the AirPlay services from their iPad to perhaps connect to an Apple projector. Okay, so we can dynamically create those groups using ClearPass just via a simple capture portal setup. So it's all about optimizing the wireless network to support those Apple protocols. So VLANs would be a traditional way in which some legacy wireless networks might start to introduce security on the wireless network. So containing users, groups of users, or applications to a particular VLAN, and then perhaps bringing them out to an external firewall and segregating at that level. Okay. With the converged devices that we have, Venue 8 Pro tablet that we have here, we've got a multitude of applications. Okay, where do you put those applications? Or where do you put that device actually to support those applications? If you're containing those devices or trying to contain the application at a VLAN level. Okay, by nature it's dynamic. Okay, so any particular time, you'll be using maybe 2 or 3 specific applications. So which VLAN is appropriate? So quite clearly, this model doesn't work by statically assigning VLANs. Okay. And the same applies in a mobility environment as well. Okay, mobile environment. So you have tablets, you have mobile devices that are moving around the workplace environment. Okay, so how do you address that with static VLANs? Okay, so the way that we do that is using the policy enforcement firewall. So based on the user device, perhaps the location of where that user is trying to authenticate, or the application, we dynamically allocate appropriate VLAN as appropriate. Okay? So it could be that purely based on Active Directory membership, you would create a VLAN. Okay? Or it could be that we have a user that's been authenticated against that user ID and dropped into a VLAN. Okay, but then he decides to fire up link application on his tablet. So we could dynamically drop that application into another VLAN. Okay, so we provide that from our controller based solution. Okay. So dynamically allocating VLANs without without configuring the wireless infrastructure, the wired infrastructure. Okay, or you can do it with the instant AP, provided that those VLANs have been manually configured on the wired infrastructure. So that's a feature of the policy enforcement firewall. Okay, and in terms of other security features that we can provide on there, is the project and print, selectively allowing that, is control of the bonjour service. Okay, so controlling those AirGroup services, blacklisting intruders and applications. Yes, we can do that using the app or blacklisting intruders. We use that using the inherent wireless intrusion protection system. We also support mobile device management, okay, with our enterprise mobility manager product, okay. So mobile device management, okay, which ties in very nicely with ClearPass, our access management solution, okay. So so if you do have employee provided devices, okay, that are lost, stolen, etc., certificates can be revoked, and applications can be resolved, okay. Or if a user trying to connect to the network doesn't comply, you know, perhaps because their antivirus is out of date or their personal firewall isn't complying, so we can drop them into a quarantine VLAN. And if you have misconfigured devices, again, so this, you know, misconfigured in terms of perhaps not running the correct operating system or patches, okay, they can be redirected to a quarantine VLAN as well, okay. So there's things that we can do, you know, from an endpoint posture assessment perspective as well. Okay, so how do we build a wireless network? Okay, so it's relatively straightforward to do. It's all about providing appropriate coverage, okay. And the way that we can do that, we do that in a couple of ways. We can do that using a desk-based planning tool that we have. So using floor plans, we'll import that into Visual RF, an application that sits inside Airwave, okay. And based on a number of parameters, so you know, some information about the building, you know, what the walls are made of, the type of environment, whether it's office, whether it's cubicles, type of throughput that you can provide. You know, we can provide an RF plan of your environment in terms of numbers of APs, where those APs are to be deployed, and the types of APs that you need. We can do an on-site RF RF survey as well, so either Dell or Nexus. That's one of the services that we could come out and do. The advantage that would have over a desk-based surveys, it also takes into consideration what the RF environment is like as well. So once we get a picture of how many APs, where those APs need to go, the types of APs, we can start to add networking to that. Is it appropriate to have a physical controller? Can we fulfill this requirement with an instant access point solution, i.e. virtual controller? Do you need some switches, LAN switches? Do you need power over Ethernet, power over Ethernet plus? Do you need additional ports? Okay, so we have those within the Dell networking portfolio as well, which are open standards, so you know, we can add them to your existing infrastructure. And then we look at the management aspect as well. Okay, so what do you need to do? Okay, do you need guest provisioning in terms of automated guest access? Are you looking at BYOD? Do you need a radius server? Okay, if so, we'll perhaps look at ClearPass, an access management solution, and then we'll have a look at the type of management that you need. So whether that can be fulfilled with Open Managed Network Manager, which is our element manager, or we look at Airwave. Okay, so looking at some of the products themselves here, this is a bit of an eye chart. I'm not going to go through all the detail on this. So this is our portfolio of controllers, hardware controllers. Okay, so I'm not going to go through this in any great detail, other than pointing out that we do have a family of controllers, okay, that have different capacities in terms of supporting APs, different throughput levels, different interfaces. Okay, and you can mix and match these, you know, in what we call a wireless mobility domain, yeah, to give you the wireless coverage that you need. And we have a whole family of access points. Again, I'm not going to go through this in any great detail, other than pointing out that there's 2 pages of this, by the way. We do have quite a portfolio of APs depending on what your needs are. And again, in a wireless environment, you can mix and match these. Okay, so I'll just look at the first 4 columns on here because these are all our 802.11 AC access points. Okay, so we do have 11N. Might still be appropriate for you. Okay, so in the left column we've got some external APs here, so intrinsically protected, for external mounting, with lightning arresters, and so on. And you have a choice of whether you want 3x3 MIMO, dual radio, single radio, and so on. And yeah, we have some wall plate mountable APs, and we also have some aesthetically pleasing APs that are designed to sit on desks. Okay, so these would typically sit in a home office environment. These would typically be configured to be a remote access point. Okay, so would sit on a desk. We also have wired ports on as well for connectivity to printers or any other wired connectivity that you might need in a home office environment. Okay. Closer look in more detail at some of those products now. So this is the AP225, which is our flagship product. It's our flagship 802.11 AC access point. So it supports 3x3 802.11 AC MIMO. So 2 radios in here, one operating at 5 gig, one operating at 2.4. The 5 gig is 11 AC. Will support up to 1.3 gigabits per second. Okay. Simultaneously, running that radio, you can run the second radio using 11N technology for speeds up to 600 meg. Okay. So almost 2 gigs worth of throughput. So we have a 2 gig connection into that access point. So 2 separate 1 gig RJ45 ports. Okay, used for capacity if you want to get the full almost 1.8 gigabits per second worth of throughput, and resilience as well. Okay, so we support those links in a link aggregation mode, so they are bonded, and if you lose one, then the other link is still available for forwarding. Our outdoor access point. Okay, so this is also AC. We have already spoken about this. It's PoE or AC powered, minus 40 degrees to plus 65 degrees, and it's rated. It's an external access point. This is the desk-based model, the IAP 155, which is typically remote branch and teleworker access point. Look at some of the controllers. So the 7200 are the flagship range of controllers that we have. So these will scale up to 2048 access points. Okay. And that's all through licensing. Okay, so you can license these with as little or as many APs that you want up to the 2048 level. Come with 4 10 gig ports, provide connectivity to your wired LAN, dual power supplies, and so on and so forth. Just saying new on this, it's a little bit out of date because it's been around for about 12 months now, but I apologise for that. Okay, very quick look at the 802.11 AC standard and what that actually means. And I'm not going to spend too much time on this slide because it's quite technical. So if we look at the diagram that we have here, which kind of shows the encoding and how we get the bandwidth. So if we look at the left-hand side of the chart, we look at the original standard for 802.11ag. We used a technology called OFDM, or orthogonal frequency division multiplexing, if I can get my teeth around that, okay, which supported 54 meg. Okay. Take that up to the 11n standard. There was some work that was done on that algorithm. Okay, and the rather than using 20 megahertz channels, 40 megahertz was used. Okay, and that was bonded together. So it was 40 megahertz channel, which actually took that up to 135 meg. Okay, with a little bit more work that was done on the algorithm. Okay, the technology was able to support up to 150 meg, okay, and that would equate to a single spatial stream. Okay, now the 11n standard allows us to support multiple spatial streams. Okay, so if you look at each spatial stream supporting 150 megabits per second, we can see from this diagram what the various tubes represent on here. You can see that three of those spatial streams, which actually used from the 11n access point, okay, would give us 450 megabits per second worth of bandwidth. The 11n standard does support 4 spatial streams, okay, which in theory would provide 600 megabits per second. Okay, not really seeing the take up of that in the industry. Okay, so 11n pretty much staying around 450 megabits per second. See how we get that with the adaptation and the improvements that were made to the encoding and the use of the channel bonding and spatial streams. Okay. With 11AC, we somebody trying to call me there. With the 11AC standard, it's basically an adaptation of the 11n standard. Okay, but what we do now is we use improved encoding, and rather than using 40 megahertz channels, we now use anything from 80 to 160 megahertz channels, and we can go up to 8 by 8. Okay, so as we can see, so if we double the channels that we have, so assuming that we're supporting 4 channels at 600 meg, we've seen improvements to the encoding, double that. That gives us a 1.3 gigabits per second, which is what we can see today. Okay, with our AC product, in theory, you can go way beyond that. Okay, 48 by 8. That's really where we get the, or how we get the speeds that we can achieve with AC. In terms of what this actually means, we can see it on this chart in terms of the channel width, okay, and the number of streams that we're using, okay. So with the 11AC standard, using the 80 megahertz channels and a device that can support 3 streams, you can get data rates of up to 1.3 gig. Okay. And so what does all that mean? It means better throughput, it means better data rates, okay. And it's actually more efficient as well, actually. So it does actually consume less power, which is quite important from a mobile device standpoint. Okay, so now we're going to have a very quick look at our access management solution, okay, which is what we call ClearPass. And what we're trying to address here is organizations that are really trying to address any of the 3 areas that we have on here, or a combination of all 3 really, which is corporate or company issue devices, or an encouragement of complete employee provision devices, or perhaps somewhere in the middle where the company will have a preferred catalogue where the employees can actually select from that catalogue. Okay, but the important thing is, how do we access any of those devices? How do we connect any of those devices onto the network by minimising the overhead on IT? Okay, and that's what ClearPass does. Okay, we also, aside this, provide a way of streamlining guest access into the network as well. Okay, so guest access through self-registration or through sponsorship. Okay, so identifying a person that you're coming to visit in a particular organisation, nominating them as a sponsor as part of your self-registration. Okay, person with grant access. Okay, so our BYOD technology really covers managing access to the network. So based on who the user is, the role that they have, perhaps the device that they're using, we can provide access rights as appropriate. Okay, and we can take a policy action on that. So whether it's restricting usage in terms of bandwidth, in terms of putting them into the right VLAN, etc. This is all covered by ClearPass. Okay, but it may well be you want to look at a full mobile device management solution as well. Okay, so if you are encouraging your users to connect onto the network using their iPads, okay, and they are connecting to company applications and then taking that data or taking those applications away from them, then we have a mobile device technology enterprise mobility manager, which allows us to sandbox company applications, company data, segregate that data away from personal data. We can revoke certificates. Okay, so we can actually prevent devices from reconnecting if they're lost or stolen, and we can actually dissolve those sandboxed applications. Okay, so if there's a possibility that an iPad is left in the back of a taxi, okay, any chance of connecting that onto the network can be minimalised or reduced. Okay, and same for any company data that's present on there. The W Series Wireless and ClearPass covers managing access to the network, and then Enterprise Mobility Manager, okay, which is a separate set of technologies available from within Dell with different mobile access management. So what does it look like in real life in terms of infrastructure connectivity? Okay, so we have the W Series access points. Okay, may or may not be connected to a physical controller. ClearPass will provide us with BYOD and GAS. This is all connected to the wired infrastructure, okay, which would love to be Dell switching, okay, but it doesn't have to be, so we are vendor agnostic, okay, and you may have a security device, and again, we'd love this to be Dell somewhere. So ClearPass is a set of licensed technologies. So out of the box, you get a radius server, and it includes a policy manager. Okay, that policy manager will provide device fingerprinting, so identification of what devices are connecting into the network. Okay. On top of that, you can apply licenses depending on what you want to do. So guest is about providing visitor and guest access management. On board is for BYOD in terms of automating the whole process of employees securely connecting their devices onto the network. Okay, and we'll see how that works in a second. Okay, and on guard, an additional security level if you want to provide endpoint health and posture assessment. Okay, so that's how it's all put together. So it's licensable technology depending on the features and the functionality that you need. Okay, so ClearPass works hand in hand with Dell Wireless and Dell switching products. It is vendor agnostic, okay, and it will work with wired and wireless networks as well. Okay, so if you already have a wireless infrastructure, okay, and you're interested in BYOD and guest, then we can look at integrating ClearPass within that. Okay. Same for your wired infrastructure as well. So if you want to extend some of these features, so guest access, for example, onto your wired infrastructure, then depending on the capabilities of your switches, then we may be able to integrate ClearPass within that existing environment. Okay, so yeah, already covered that. So applicable to any network, doesn't matter what the device is. So we will support iOS, Android, Windows, macOS. Okay, not tied into any user or type of user. So it could be employees, contractors, visitors, etc. Yeah, and it covers mobility, BYOD. So radius server in there. So if you just want to use this to replace a radius server, then you could do that. Guest management, NAC, but also visibility as well. So there's some reporting that's also built into ClearPass that will give you visibility into how the access management solution is performing. Okay, so the architecture of ClearPass, it uses a publisher and subscriber model, okay, or so from a resilience perspective, if you're buying ClearPass as a physical appliance, you can buy a single appliance, but we typically create a cluster of publishers and subscribers, or it is available as a VMware application. So you can build a resilient solution using the inherent capabilities of a virtual environment. Okay, and it will talk to your network devices, so whether they're APs, controllers, switches, which we call policy enforcement points, okay, which are allowing users and endpoints to attach as appropriate. Okay, and that also would tie in with any identity store that you might have in your network, such as Active Directory. We have customizable captive portals on the system. Okay, so from a guest registration perspective, you can customize the look and the feel of what those registration portals might look like. Okay, and these are some real examples that we have on here. So thank you, Benny's, Westfield, guest registration. So some of these are a bit American. Except this one, which is Australian. So this was for the Australian Open, and these are all genuine what we call skins that we developed, okay, for these particular events or retail outlets. Qantas, so on. This was one that was created for the Blue Water Shopping Centre. Okay, so one of the things that you can do is you can start to collect visitor intelligence. So as part of the visitor enrollment process, you can provide customized screens, customized forms to actually get some level of detail or snippet some information from those guests. So in this particular example, we're collecting Blue Water, we're collecting email addresses and a birth date. Okay, and the way that they were using that was then mailing out a discount voucher, okay, on or near to the birthday the person applied for registration, and a discount voucher for one of the retail outlets within the shopping centre. Okay, so the access management solution, whether you're using ClearPass or whether just using the policy enforcement firewall, we define that as a context-aware solution. Okay, and it's context-aware because it's based on a number of parameters. So we can provide access rights as appropriate based on a number of criteria. So one of the things that we can do is what we call user fingerprinting. So tied in with Active Directory, either as an individual user or against a group. Okay, we can define access as appropriate. Okay, access rights as appropriate. Okay, that's what we call user. We can also do device fingerprinting as well, actually. So it could be the same user that's logged in, got the same Active Directory credentials, but rather than trying to connect to the network using the corporate provided Windows device, perhaps bringing an iPad. Okay. So ClearPass will do, as part of the authentication, device fingerprinting. So it will look at the operating system, it will look at the browser that's being used, it will look at radius attributes coming back, it will look at a MAC address, and from that it will determine what the device is. So that is Safari, that it's running iOS, for example, we see the Apple vendor code in the MAC address. Chances are it's going to be an iPad. Okay. So it's no longer the same Windows device that that user is expected to connect to. So in this particular example, we now divert that user to ClearPass for self-registration. And you can define, what you need that user to do as part of that self-registration process. So it may well be they just provide details, or they agree to terms and conditions of usage, and so on. Once they've gone through that process, okay, we do two things. So we can push an 802.1x package out. Okay, so authentication and encryption. We can also put a certificate on that device as well. Okay. So next time that user connects, okay, doesn't have to go through the registration process, okay, unless you manually revoke the certificate, or the certificate expires, or you blacklist that user. And we can also provide context access control around time of day, and also the location as well. Okay, so apply appropriate access rules based on those two additional parameters. And one thing that we've already spoken about as well is also applications. Okay, so in this example here, we're providing some QoS to the applications that are being used by this particular user. And adaptive radio management, I've already spoken about. It means that we always optimize the wireless airspace from a user perspective. And Airwave gives us full visibility, not only into the wireless components themselves, but also we can look at what users are connected, where they're connected, and how they're experiencing the wireless network, okay, in terms of wireless health. So that was ClearPass, the access management solution. Okay. So in the next 5 minutes or so, I'll just cover off how we manage our wireless infrastructure. Okay. And we have two packages. So first off, we have Airwave. Okay. So Airwave is the management tool which although it's optimized for Dell W series products, it is multi-vendor, okay, and it will cover wired devices as well. So out of the box, it will cover other vendor wireless products. So the likes of Trapeze, we've still got Trapeze kicking around, Cisco, for example. Out of the box Cisco switches, we can manage those. Not only does Airwave give us full visibility of the networking components, okay, it will also provide us with a comprehensive view of the wireless infrastructure. Okay, so it will provide us with floor plans and heat maps. Okay, so where the APs are located on those floor plans and how those APs are performing. So what the coverage levels are. Okay, in terms of RF settings and data rates. We can also see the end devices themselves connected onto those access points. Okay. Also includes Rapids, which is the Rogue AP IDS application. So from within Airwave, we can define the policy action to be taken against any rogue APs that are detected. Okay, from within the visual RF plan, that's where we can identify where those rogue APs are located, as well as we can set this up to send an alert if a rogue AP is detected on the system, and then use the visual RF plan to try and identify, within a certain distance of where that rogue AP may be. Okay. And it might not be something malicious, it may be that somebody's just brought something in from home and plugged it into RJ45 port under their desk because they want to get wireless connectivity, but it actually creating a security problem. It does have comprehensive reporting capabilities in this as well. So depending on the volumes of data you're collecting, you could probably get somewhere in the region of a year's worth of data collected in Airwave. Okay, and that's all data that you can historically report on. So there's a number of inbuilt reports in the system which you can use. So out of the box you can use those inbuilt reports, or you can create your own custom reports as well. Alongside that, we have Open Managed Network Manager. Okay. And this is more of an element manager or an SNMP manager. So from a wireless perspective, we will manage the controllers at an SNMP level. This won't give us the visibility into the wireless devices that are connecting or the users. Okay, but what this will provide us with, it will provide us management of your wired infrastructure as well. Okay, so out of the box it will support Dell, it will support Cisco, it will support Juniper. Okay, we can integrate other vendors in here at an SMP level. We can do a discovery of your network. We can, once we've discovered the network, we can provide topology maps. We can manage the equipment, so provide inventory reports, etc. We can do performance and event management and scheduling of software and firmware updates. So just looking at some of the pain points that Open Managed Network Manager might address in more detail. So a slow network, for example, could be resolved using the inbuilt traffic analysis tool. Okay. You may want to use it for deploying firmware or software updates. So these are updates that can be pushed out to multiple switches or multiple controllers and multiple APs. Okay, and you can schedule that out of hours. ProScan tool allows us to have a standard or a policy around configuration. Okay. So whether that's something quite official like Sarbanes-Oxley or PCI, or your own corporate standards. Okay, you might have a policy around a particular set of features, or you may want to exclude a certain set of features or functionality. A good example of that would be on a wireless network. You might say, I don't want any WEP, okay, which is understandable, security flaws, okay. So you can define that as within ProScan, saying, well, any wireless device that's configured with WEP is out of policy, okay, and ProScan would detect that. So visibility into users and applications. Yeah, we can see that using the traffic analyzer. We've got the inventory tool in there, so we can look at what devices are connecting, how they're connected using topology maps. Adaptive CLI, so if you want to get into network switches, you want to get into the wireless devices using CLI, you can do that. Okay. The Open Manager will actually help you to create or deploy some of those CLI scripts through macros. Okay. So out of the box, there are some standard sort of macros in there for sort of standard-based, configuration activities, or you can create your own. Okay. And you can also use it for alarms and events, traps, etc. Issues on the network. It will detect all those and correlate. And you can also use it for backing up something. So that is Open Managed Network Manager, and there's just some screenshots there that you can see of some of the applications. Okay, so to summarize then, the Dell W series, we see it as being one of the best in the industry, okay, and one of the best in the industry in terms of the depth and the breadth of the portfolio, okay, so the flexibility and being able to address those different types of scenarios, so whether it's a branch office, remote office, large campus, small wireless deployment. Okay. We also have large number of references, so we've got broad customer coverage, both geographically, so on a global basis, yeah, and also across different verticals. Mobility that works because it's reliable, with the adaptive radio management, with the ability to be able to build redundancy into the system, and the inherent security. It makes it very, very secure and available. Context-aware security means that we can apply policies based on user, device, applications, location, time, etc. Okay. And we can optimize multimedia applications using the QoS. We have a BYOD and guest offering, so if that's something that's of interest to you, then we can do that. And also mobile device management as well, using the Dell Enterprise Mobility Manager platform. And we have an extended lifetime warranty on this product. Okay, so all the APs have a full lifetime warranty. Okay, so what that means is for the life that you own that AP and its true lifetime, okay, so whether it's 10 years, 20 years from now, Dell are obliged to replace that AP, okay, for you. If it's not currently available, then we are contractually obliged to replace that with the nearest equivalent at the time. For the controllers, that lifetime warranty basically means that 5 years after end of sale, we will extend. Okay, so we started off that slide, this slide set, this presentation with the title, meeting next generation enterprise and how we do that. Okay, and I think we have ticked in all the boxes because we do have flexibility of choices in terms of deployment. Okay, whether it's controllerless, etc. We have the reliable Wi-Fi, the adaptive radio management, QoS ability, context-aware mobility, so applying policies as appropriate, BYOD and security. We've spoken about that, very much part of the portfolio. Number of ways in which you can manage devices, whether it's using Open Managed Network Manager or using Airwave or a combination of the two. You really have some flexibility there. We apply open standards not only to our wireless offerings, also to our wired as well. Okay, So the Dell Wireless specifically, we will overlay that onto any vendor's wired infrastructure. Okay, it's fully interoperable. Okay, Airwave is multi-vendor, open manage, network manager out of the box, supports Dell, Cisco, Juniper, HP, and so forth. And if you're looking at the wired portfolio, again, we adhere to open standards. Okay, so you could have a Cisco core connecting to a Dell M-Series Edge. And in terms of support and deployment services, you can come to Dell, you can look at our support packages, our deployment packages, or you can talk to Nexus, and Nexus also have a comprehensive portfolio of deployment and support services.